All right. So hello everyone, welcome back. And today we're going to be continuing where we left off last time, which is scope. So what is scope? Scope of variable or function defines the context in which that variable or function is recognized, right? So basically what when we define a variable, there's a specific context in which you can use it, right? So we'll see what that means. Variables we've defined and used in class so far have a global scope. That means that they can be used anywhere in our code, right? So if we create a variable, we have been able to use it within that piece of code wherever we want it, right? So if a variable is defined within a function, it is part of the local scope of that function and cannot be accessed outside of the scope. So we'll just have a look at this, right? So for example, if you create a variable called x equals 10 and you print it over here, it will work. And then if you create a function, you can also use this variable x inside that function, right? So if we run this piece of code, we'll get this answer. But if you define a variable inside a function and then try to access it outside of the function, it will throw an error, right? So let's have a look at this. All right, so this is the function we were working with last time. So let's get rid of all of this code for now and create a new simpler function. Let's just call it make var x, right? And this function will take no variables. And inside this function, we'll just define a variable x, give it the value 10, and print it out, right? Simple function. And to use this function, we'll just say make var x, right? And if I run this, we'll get this over here, right? Because that is what the function defines it. We first have a variable x with the value 10, and then we print it out. But if I try to access the variable x that we created inside, so if I say print x, right, and I try to run this piece of code, this will throw us an error, right? It says name x is not defined. And why is that? Because we define this variable inside the function, right? If we define a variable inside a function, we cannot use it outside of that function. So that is what scope is, essentially. If you create a variable within a certain scope, it cannot be used outside of that scope, right? And when you create a variable in here, let's say I create y equals 10, this variable has been created in what we call the global scope because it is not inside any function. It is outside of the functions. So it can be used by any of the functions as well, right? So we can say y equals y plus 1, or the short form of this would be y plus equals 1, right? And if we do print y, it gives us local variable y referenced before assignment. Hmm. Okay, let me just see why this is happening. Hmm. Okay, so what if we try to do print y in here? Will that work? Okay, so we can access a global variable inside of a function, but apparently we cannot assign any values to it, right? So if we do this, this works. But if we try to change the value of a global variable, that will not work. Any questions so far? So you can have multiple variables with the same name, one in the global scope and others inside the scope of functions. This is called shadowing, right? So you can create a variable called x, and you can also create another variable called x within the function, right? You can get a reference to a global variable from within a local scope using the global keyword, right? So this is what we were looking at earlier. So if we try to use a global variable within a function, we first have to reference it by saying global followed by the variable. So let's look at our example again. So over here, if we try to do y plus equals 1, we get an error, right? It says unresolved reference y. So what we can do is we can reference it by saying global and y, right? So if we do this and then try to run it, you'll see the value of y increased by 1 inside of the function. And I'll get rid of all the x's just to make this a little clearer. And we'll change the name of this function, call it add to y, and call this function, right? So if I call it once, the value increases by 1, right? And if I call it multiple times, it will keep increasing the value by 1 each time, right? So at the end, we get 13. So this is how you can access a global variable inside of your own function, right? Any questions? No? Okay. So again, I would recommend going to W3 schools and learning more about functions and scope and doing some of the exercises present over there, right? So before we now move on to our next topic, I would quickly like to discuss the two new assignments. So let me get over there. So we have to start sharing my screen again. All right, so this is what you'll see, right? So this is assignment 4. So assignment 4 is based on loops. It is a very simple assignment. There's only 3 questions, right? And you have to create a loop or multiple loops for each of them. So let's have a look at the first question over here. So write a program that accepts a number and outputs valid if it is 5 numbers long, right? So all we're trying to do is, let's say we have a number 1, 2, 3, 4. This has 4 digits. So we'll say invalid, right? So you'll basically be having one input and looping through it, you will give the answer, right? So I won't give any hints right now. I would like you to think about this a little bit yourself. The only hint I'll give you is the modulo operator might help here. And then example 2, if you have 5 digits, we do get the answer as valid, right? So now question 2 tells you to modify that program in question 1 that adds all the digits of the entered number and display it in the form of an equation using loops, right? So what we basically want to do is, if we have a number, let's say 56781, we want to create a loop that writes this down, right? So we don't just want the answer, we also want this entire sentence to be written down here, right? So it should say 5 plus 6 plus 7 plus 8 plus 1 equals 27 in the console window. So another example is 1, 2, 3, 4, 5, and you'll be writing down the sum as a representation and then equals to, and then the actual sum, right? So it says the left-hand side of the answer must be dynamic. What does that mean? That simply means that you will have a variable x at the beginning, and based on that variable, you will create your loop, right? So you won't enter a number into your loop. You will simply change the value of the variable x to get the desired output. Modify the program that you've written in question 1 to capture below scenarios, right? If there's a number 2 in the entered number, then do not add. So for example, x equals 73251. So this should say question 2 over here. That's a little bit of a mistype, but you have to modify the program written in question 2, not question 1. So what you'll basically do is if there's a 2 and in the entered numbers, you will ignore the 2, right? So 73251, we only write 735 and 1. Is that clear? And then lastly, if there's a number 9 in the entered numbers, then multiply it by 2 and add, right? So you'll basically, instead of adding 2, you'll be adding 18 for every 2, right? Sounds good. Any questions? Any questions on how the output should look or anything like that?
No.
Okay, perfect. Let's have a look at assignment 5 then. So assignment 5 will be based more around the last lecture, right, which was functions. So for each of the below questions, write a function to solve the use case at hand and provide a few examples of using the function. The questions will get increasingly challenging, both technically and in terms of being less descriptive as to exactly what is required to accomplish the task as you progress through the assignment. Make sure to document all your functions with doc strings, right? So make sure you add proper documentation about how your function works. So the first one in here is write a function that accepts two arguments, a numeric value, as well as a list of numeric values. This function will be used to multiply each value in the list by the number passed and return the resulting list after this multiplication has been applied. So for example, if I give the input 2 and 1, 2, 3, 4, 5, the result should be 2, 4, 6, 8, 10. So your function will have two arguments, and you will basically have the first argument as the multiplier, right? So 2 in this case, and the second argument will be a list. So you will loop through that list and multiply each number with 2 and give a resulting list out. Then the second one is write a function that converts a temperature entered in Fahrenheit to Celsius. This is quite straightforward, right? So you will take the input as temperature in Fahrenheit and then give the output for temperature in Celsius, right? Create a function that accepts three arguments corresponding to the current temperature in degrees Fahrenheit or Celsius, right? An indicator telling if the temperature is in Fahrenheit or Celsius, and the current weather, right? And print out what the caller should wear based on these values according to the following. So you will have multiple conditions over here, and based on these conditions, you will give the desired output. So I'll let you guys read through this. All right. So there's also two more that I'm not going to go through right now, but these will be for extra credit, right? So all you need to do is the first three questions. But if you are able to get to questions 4 and 5, I would recommend you do so. These will be more challenging, but still doable, right? Any questions on this assignment? Okay. If there are any questions that come up later in your mind, feel free to put them in chat. So I'm just going to take a couple of minutes here to open up the new topic assignment, sorry, presentation. So go grab a cup of water or something if you need to, and we'll see you in 2 minutes. All right. So our next topic that we're going to look at is classes and error handling in Python, right? So object-oriented programming. So what is object-oriented programming? Just about everything in Python is considered an object, right? So what is an object? An object can have properties or attributes as well as methods, right? So properties are like variables that are part of an object, and they are only referenceable through the object using dot notation. Methods are like functions that are defined within or called on an object using dot notation, right? So who can give me an example of an object that we've already seen? Any ideas? No? Okay. So we have looked at a bunch of objects already, which are our lists, our tuples, and all of our um, data structures, right? So all of our data structures are, um, so all of our instances of data structures are also objects, right? Because all of them have functions that we can call that are called methods. And that is why they are also objects, right? So what is a class? A class is essentially a template that is used to define a custom object type, right? So the definition of how an object should be is called a class. Its properties and attributes, its methods and its behaviors, right? So all of these things will be defined within the class. Classes are defined using the class keyword. Properties or attributes and methods of a class are indented underneath the class declaration, right? We can create instances of a class by calling the class name followed by parentheses. Similar to methods, we can access an instance of class using dot notation, right? So that we can get their attributes using the dot notation. So let's have a look at our first class. All right, so let's say we want to make a class and let's call it student. So now let's give the class student three properties, right? So first let's give it a capital S, and then we'll give it three properties. So the first property we'll give it is first name. So we can define a default value. Let's say the default value is John. Then we'll give it a last name. Let's say the default value is Doe. And then we'll give it another property. Let's call it age and give it the default value of 20. All right. So now what we can do is we can create a variable. Let's call it new student, and to initialize it as an object of type student, what we can do is we can say student and then open parentheses. So now new student is an instance of the class student. So student is a class and it defines an object, right? And new student is an object with the definition of this, right? Student. So now what we can do is we can access the properties of our object, right? So we can say new student dot first name, right? So if I print this out, we get John, right? So that was just a reformatting. So I would recommend if you do get those kind of errors, you do what it says because it just makes your code look nicer, right? So anyways, we were saying print new student dot first name. So in the bottom over here, you can see we got the first name that is stored inside the class, right? And similarly, we can print out the other ones as well. Right? So if I press run, we get all three of these, right? Um, so I see a no in chat. Could you be more specific? Is there something you didn't understand? Um, all right. Okay, no problem. Looks like it was accidental. All right. So now what we can do is we can also give values to these, right? So let's say our new student that we want to make should not have the values of should not have the default values, right? We can give it whatever values we want, right? So we can say, so let's say Josh, and then new student dot last name and Joe, and then we can say new student dot age is 50, right? And now if we just copy all of this and try to print out everything again, you'll see the values have now been changed, right? So you can change the values for that particular object without changing the definition. So every class has an init function, right? So every time you instantiate a new instance of this class, this function is automatically called. And if you do not define this function, it simply consists of uh, initializing all of your properties to their default values, right? We use the init function to dynamically assign values of a new object instance properties, right? So let's have a look at the class we just made. So let's get rid of all of this. So as it is, our student class is kind of not very useful, right? Because we can only define a student, and when we do define it, it has these default values. What if we make it more dynamic? What if we make it so that it can accept three values in these parentheses, and then those three values can be assigned to each of these properties, right? So we can actually do that. So the way to do that is first we define the init function, right? So once you do a double underscore, you will see the init function pop up over here. This is the one we want. So the self keyword references to the object itself. We leave that value untouched, and we'll introduce three new variables here, right? So the first one is first name, then we have last name, and then we have the age, right? And what we'll do is we'll say self dot first name equals first name, then self dot last name equals last name, and self dot age equals age, right? Now what we can do is when we call the initialization of student, we can define all three of these values and assign them, right? So we can say Josh, comma, Joe, comma, let's say 50. Right? And now if I just do print new student and run this piece of code, okay, so you'll see this, right? So new student is an object. We didn't call any of its properties. So to see the properties, we'll have to do first name, and then we can create more of these here. So print new student dot last name, and then print new student dot age, right? So if I run this, as you can see, we have instantiated our new student with these values, right? And to make it more meaningful, we can replace this with Josh object, right? And then replace that everywhere. So now similar to this Josh object, we can define another student. Let's call them John object. And we can initialize this with completely different values, right? So we can say Josh, sorry, John, comma, Max, comma, let's say 25, right? And if I just copy this and paste it here and replace the Josh objects with just John. So now what I can do is, if I run it, you'll see the second object that we created has the values that we defined over here, right? So this is how you can dynamically assign values to properties based on what the object is representing, right? Everyone with me so far? Any questions?
I'm good.
Okay, all right. Let's go to the presentation. So notice that we don't include the self parameter when actually creating the instance, right? So when you actually create the instance of the class, you do not use the self keyword. It is implied. So what are methods? Methods are like functions that are defined within and called on an object using dot notation. We define methods just like functions, except they are indented underneath a class, right? And in addition to this, they will also all have the self keyword to identify them as functions that are being defined for that class, right? And for you to be able to use the properties of that class within the function. So let's have a look at this. All right. So this is kind of tedious, right? If we have to print out all three of these properties, we're having to write down a lot. So let's create a function that prints everything out for us. So print info, let's call it. Right? And then as you can see, the self keyword auto inserts itself. So we let it stay there and go to the next line. So what do we want to do? We want to print everything out. right? So we'll say print, and then inside here we can say student's name is, and then we can put a, so we can put add sign to append, and we can just self dot first name, and then plus we put another space here between the first name and the last name, and then we say self dot last name, right? And then we put another space and say with the age, and then lastly we put in the age, right? So self dot age. So now we have defined a function that prints out all the information for us. So let's replace it over here and say Josh object dot print info, right? And similarly for John object, let's replace all of this and write John object dot print info, right? So now if I try to run this, we get can only concatenate a string to a string, not int. So we have tried over here to add an integer to a string value. So that is not possible. So let's first convert it to a string value before we add it. So now this should run fine. And here we go. Okay. So as we can see, this is much more cleaner, and this is how we define a function, right? So we have the self keyword so that we can access all of the properties inside, and then this can be called on any instance of that class, right? Please feel free to unmute yourself at any time if you do have questions. But this is how we instantiate first the properties, and then we use those properties to define various methods, right? So what is the self parameter? Let's have another look at that. Self refers to the current instance of the class, and we use it throughout the class definition to access the class properties and methods, right? So within the class definition, you will have various functions, right? So you might even want to use functions within functions. And to do that, you would want to use the self keyword followed by a dot, and then you can use the method inside, right? So as we can see in this example, there are two functions, right? One is the introduce self to, right? And all this function does is it simply prints out the name, right? And then we have another function called the describe self to. And inside this function, we first call the introduce self to function to print out just the name. And then we print out another sentence, which actually contains the information about age, occupation, and location, right? So just have a look at this example for a minute. But this is how the self keyword is used to call names of properties within functions, and also to call the class functions within other class functions. All right, so what is a docstring? These are very similar to what we saw them as in functions, right? So these will just define what your class is doing and is just documentation, right? Again, there is no right or wrong format, but the format that is provided by default is really nice, right? So let's have a look at that. So over here, we can create our docs file. So we put three double inverted commas, and when we press enter, it should have given us a docstring. All right, so if it does not give you a docstring, you can still write the words abstract, right? And then under the abstract, you will basically try to define what your class is doing, right? So in our case, we'll say this class defines a student, right? And then what we can do is we can have the properties, right? So our properties are first name, and we'll define this as first name student. And then we put other property, call it last name, and this defines the last name of the student. And lastly, we have age, which defines the age of student, right? So now for each of the individual functions, you can just go in here and create their own docstring, right? So this time it came by default, right? So it will give you three parameters. So the first one is student's first name, right? So we can just copy this line. And for the second one, we can copy this. Oops. And for the last one, we'll copy this one, right? And we'll also give it an abstract. And inside the abstract, we say initializes the class instance, right? And then similarly, we can create another docstring for this one. And we can say abstract prints out student information in a nice format, right? Return values, we are not returning anything. So we can get rid of this one, right? So this is how you can create docstrings for your own class, right? So this is a class docstring, and here we have the method or function docstring, right? So what are errors and exceptions? Before we get into errors and exceptions, are there any doubts in classes? All right, let me just have a quick look at how much more is left in here, since we just have 14 minutes. Yeah, this will take a little bit longer than we have here. So let's stop it at classes for today, and we'll continue with errors and exceptions next time. All right, I'm going to stop recording.